Okay. Today we have a lesson about nuclear fission. We're going to continue talking about nuclear fission. As I told you before, nuclear fission occurs when large atom splits into two smaller atoms, and this process produces a huge amount of energy and three neutrons.
السلام عليكم.
Alaykum salam. Welcome, Mubarak. This process is nuclear fission and produces three moving electrons. These electrons are ready to attack new atoms of the fuel. This is called the fuel to produce more energy and more free electrons. But here we have two problems. The first problem is the produced neutrons are very fast moving. So we have to slow them down. The second problem is the energy produced is very high and it can melt the reactor itself. It can melt the reactor itself. To overcome the first problem, we have to slow down the free moving electrons. The process of slowing down free moving electrons is called the nuclear moderation. Nuclear moderation. Sultan Idris, can you read nuclear
Hello,
moderation?
Yusuf. Nuclear moderation is a process that slows down neutrons so that the reactor fuel can capture them to continue the chain reaction.
Thank you. Nuclear moderation is a process that
You're
slows down neutrons. Why we slow down the neutrons? If the neutrons are very fast, they can penetrate the atoms, the new atoms, and the reaction will not occur. So we have to slow them down to make them enter the atom of uranium and make this atom unstable and fission occur. But if the electron is too fast, like this, it can pass from the other side without splitting the atom. So nuclear moderation solves this problem. It's a process that slows down neutrons to permit the fuel capture them. Here, moderation can be done by water and by carbon. The second is called the neutron absorption. If the number of neutrons increase too much, we cannot control the reaction, and this may cause the reactor to explode. So we have to absorb some of the neutrons by neutron absorption. It's a process that decreases the number of slow moving neutrons. So you have to differentiate between neutron absorption and the neutron moderation. Nuclear moderation to slow down neutrons, but neutron absorption is to slow down neutrons by decreasing the number or decrease the number of the neutrons itself. There is a big disadvantage of nuclear energy is nuclear waste. As you know, guys, the nuclear waste, which is produced from nuclear reactions or nuclear reactors, these wastes are very dangerous for animals and the plants and the humans. Why? Because these wastes emit particles and radiation that can make damage for health and for plants as well. So this is a big problem that countries try to solve it by digging deep holes in the desert and so on to bury the waste inside it. So if I ask you what is the disadvantage of nuclear waste, of nuclear reaction, you say the nuclear waste. Uh, Till now, we are still in nuclear fusion. Nuclear fusion simply when one atom splits into two atoms and produce a large amount of energy. The second process is the opposite of fusion. In this process, two small atoms combine together and they give you large atom plus energy. This process is called the nuclear fusion. Nuclear fusion, two smaller atoms combine to give you bigger atom and produce high energy. The problem here, this process needs very high amount of heat, very high amount of heat, and we cannot provide this heat on Earth. So this can happen where I told you before, on the sun, because the sun is very hot and it can produce this very high amount of heat that can start the nuclear fusion. Okay, Mubarak, can you say fusion? What's fusion?
Fusion occurs when nuclei combine to produce a muscle a nucleus of greater mass.
Very nice. So fusion here occur when nuclei combine to produce nucleus of great mass. It's written here in solar fusion, hydrogen nuclei fuse to make helium nuclei. So here, the small atoms are hydrogen nuclei. The massive or the heavier atom is helium. And the problem here is what? Why this fusion needs very high amount of heat? Because protons are positive, as you know, and they repel each other. So when you make them combine or come together, you have to put them under very high temperature and pressure. The product of this process, you have here 4 hydrogen atoms. It will give you 1 helium atom and a particle called positron. What is the positron? You didn't hear about it before. Positron is a very small particle, looks like the electron, but it's positive. Again, positron is a very small particle in the size of electron, but it has positive charge. The mass is almost 0. Fusion reaction, small nuclei combine, release much more energy than fission reaction. What we have here. Okay, fusion reaction occur only at very high temperature and it must be more than 4,000 million. Imagine, guys, it's a very high temperature and it's impossible to provide it. To provide this energy on Earth, you need atomic bomb. The atomic bomb can give you this heat to start a new reaction. So written here, the use of controlled nuclear fusion as energy source on Earth is appealing. Some countries want to do it. The potential fuel are inexpensive because it's a hydrogen. You can get hydrogen from air, from seawater, so it is available. The problem here with the high temperature needed to start the reaction. I told you it's 4 million, 4 million degrees Celsius. And to control this reaction also. To provide this high energy, we can use fission bomb. We can use fission bomb. It's a triggering device used for setting off hydrogen bomb, which is an uncontrolled fusion device. You cannot control the fusion process. Here, guys, as we said, to make fusion, we need two smaller nuclei or two smaller atoms and give you heavier atoms. The high temperature needed to support fusion exists within the sun core. As we studied before, the sun has life cycle. Today, or in the present time, this reaction is occurring between hydrogen atoms to produce helium. But in the future, helium atom will combine to make beryllium. And this will change the heat and radiation coming from the sun. Okay. Who can answer this question? Sultan Idris, read.
Yes, yeah, Mr.
Can you complete this in solar?
Yes, choose the correct words for the spaces. In solar fusion,
Uh,
uh,
what nuclei
helium. Helium.
fuse to form what nuclei? You mean here
Helium.
helium? Mm,
Yes, here helium to form.
mm.
Help me, Mr.
Beryllium?
Form what?
Okay, but this is in the future. I need what happens now in solar fusion? Hydrogen nuclei
Yes,
fuse to form what
form
nuclei?
oxygen.
Mm.
Oxygen,
Mubarak al-Hilan. He said
nitrogen.
hydrogen fuse to form oxygen. Is this correct?
Yes. I
Mubarak.
don't think so.
Hydrogen fuse to
Yes, yes.
form.
Can you hear me, Mr.?
Yes, I hear you. Hydrogen fuse to form
Helium.
helium. Excellent. So in the first space, we have to write hydrogen. In
Hydrogen.
the next
And the second
space,
helium.
helium. Excellent. Now, guys, I'd like to show you a short video about fusion. And I need you to confirm that you hear the sound and everything is all right, okay? Nuclear fusion.
proton fusion, two hydrogen nuclei, or produce energy in the
Please,
sun.
Mubarak, do you hear the sound of the video?
Extreme high temperatures
Yes,
and
clear.
pressures
I can hear.
inside the sun's
Sorry?
Yes, I can hear the sound.
Good.
core provide a setting that is a
Let's
magnificent
start it.
universe. Nuclear fusion is the main method used to produce energy in the sun. Extremely high temperatures and pressures inside the sun's core provide a setting that is ideal for fusion. The proton-proton chain is a common name for the fusion process that occurs in the sun. Here are the basic steps of the proton-proton chain. 1. Proton-proton fusion. In the first step of proton-proton fusion, two hydrogen nuclei, or protons, collide, thus overcoming the electrostatic repulsion between them.
So here, guys, what started the fusion? Two hydrogen nuclei.
As a result of this occurrence, a proton changes into a neutron by a process.
Second step, a proton changed to what? Trace. The proton changed into
Nitrogen.
neutron. Again, proton changed into
Neutron.
neutron.
Process
Excellent.
known as beta plus decay, emitting a
This
positron
process
and a
is called
neutrino in the process.
beta decay, and it produces positron and neutrino.
The second proton is unaltered. Therefore, the end products of this reaction is a deuterium nucleus, which is one
This is called deuterium nucleus. It has proton, neutron, positron, neutrino.
proton and one neutron. 2. Deuterium capture. In the second step, a second proton is added to the deuterium nucleus created in the first step to create a helium-3 nucleus, two protons, and one neutron. A gamma-ray photon is released by this process. This brings us on to number 3. Helium-3 fusion. There are two possible routes for the helium-3 nucleus, created in the step explained. These are: Path 1. Helium-3 fusion. When two helium-3 nuclei collide, a helium-4 nucleus, which consists of two protons and two neutrons, are produced. Two protons, two gamma-ray photons, and a significant quantity of energy are released in this process. Path 2. Helium-3 capture. A helium-3 nucleus captures a helium-4 nucleus to create a beryllium-7 nucleus, which contains 4 protons and 3 neutrons. A gamma-ray photon is released by this process. 4. Beryllium-7 decay. A lithium-7 nucleus, which is 3 protons and 4 neutrons, is created when the beryllium-7 nucleus experiences beta- decay. An electron, an antineutrino, as well as some energy, are released in this process. The lithium-7 nucleus does not directly take part in subsequent fusion processes within the Sun after the beryllium-7 decay. As was mentioned in the earlier steps of the proton-proton chain, the primary reactions in the Sun's core involve the fusion of protons to generate helium nuclei. The proton-proton chain, in its entirety, consists of a succession of fusion reactions that change hydrogen atoms into helium atoms, thus releasing energy in the form of gamma-ray photons and other particles.
So the conclusion is, when hydrogen atoms collide together and fuse together, they form helium nuclei and energy in the form of alpha and beta radiation. Okay, guys, I have here a worksheet about the lesson. Let me share it with you. Okay, Mubarak, can you read the first question?
Yes.
What
What
process?
process describes two small nuclei combining into a larger nucleus?
Yes, two small nuclei combine to large nuclei.
Fission.
Yes, excellent. This is fission. But as I said, fusion is wrong because fusion, two small nuclei combine to form again. Let's go back. Two small nuclei combine to large nucleus. This is fusion, Mubarak. Why? Because fission, we have already large nuclei split into two smaller nuclei, like this photo. Alpha decay and beta decay, this is not in the lesson. This is another type of radiation. So the answer is fusion, two small nuclei to form large nucleus. Sultan Idris, number 2.
What process is described by the splitting of a nucleus into smaller nuclei?
You have two
Fusion.
choices, fusion and fission.
Yes, fusion. Oh, fission.
Fission, because fusion in the previous one, two small nuclei combine to form a large one. This is fission. Mubarak, 3.
Yes, Mr. Number
Read
3.
now. Yes.
What nuclear process is shown in the picture?
Okay.
Fusion.
Excellent. Fusion. Because here we have what? Helium atom and energy. Very nice. Sultan, 4.
The nuclear equation shows model which nuclear process?
He means this model.
Yes. Fission.
This is fission.
هذا gamma emission معلش.
Fission or fusion?
Fusion.
Fusion. Very good. Because we have two small nuclei and they give us one bigger nuclei. Which nuclear process is shown in the picture? Fission or fusion? Here, guys, I have big nuclei splits into two. Then each big nuclei splits into two, and so on. This is fission. Number 6, the nuclear equation shown models which process? We have here uranium is struck by neutron and they give us two smaller nuclei. This is also fission. Which material is responsible for initiating and continuing the chain reaction? Neutron, uranium, krypton, barium. He needs material, so we choose uranium. Which of the following is not true statement about nuclear fission? Who can answer? If you know it, tell me, Mubarak or Sultan. Which is not true about fission. All of them is correct except one. Quickly, guys.
I think A.
Okay, and you, Sultan.
Yes.